Lake incentives are formed a part of high-altitude nature reserve. 7 underground spring nature of this picture is best seen nestling in eucalyptus in this wood. It runs 300 km from south to north, and there are over 2,000 industrial facilities arranged along its bank. 280 tons of toxic waste is dumped to the river every day.
Di mana sungai tersebut adalah sungai terkotor di dunia.
Hi, Assalamualaikum and very good day to all of you. Welcome to our presentation. So, for the first, I would like to introduce ourselves first. My name is Muhammad Zikry Azib bin Zamrie with ID matrix number TC18014. And my left side will be my partner, which is
Thibashini daughter of Selvam, TC18010.
We are in group 25 and our supervisor is Dr. Nasrullah, with glamour call as Dr. Yo. For a start, our project title is Treatment of Textile Waste using BioChar based palm oil meal sludge, or we can call it as a POME. Let us start with our background studies. Palm oil is the second largest vegetable oil in the world, this accordingly to global demand. Palm oil is the natural resources that thrive Malaysia in tropical climate. In 2017, Malaysia had a total 454 palm oil mill with a production capacity of approximately 112 million tonnes of fresh fruit bunch. After Indonesia, it is second largest producer of product. Malaysia has currently produced 39% of world palm oil and export 44% of it. This accordingly to the Begum by year 2019. By this result, the continuous expansion of palm oil plantation not only lead to the large change in large use type, but also serious threat to the environment, including reduce the biodiversity in forest ecosystem, increase greenhouse gases emission and water pollution. In Malaysia alone, 43.29 million cubic per meter of POME are generated per year, and it constitutes to a serious environmental pollution by releasing to the environment, especially in waterway.
Proceed with problem statement. Palm oil has made impressive and sustained growth in the global market over past 4 decades. This led to the generation of large amount of oil palm industry waste as like empty fruit bunch, massive from food fiber, palm kernel shell, and etc. The presence of these wastes from oil palm industry has generated a significant disposal problem. To achieve the best solution for using the oil palm industry waste, a combination of technical, economical, energy balance and environmental consideration must be maintained, whereby these wastes can be used to treat textile industry wastewater. At textile industry wastewater has high concentration of total dissolved solid and suspended solid due to their dye stuff.
Okay, this section will be our objective and goal for this project. The aim of this study is to produce biochar from sludge of palm oil meal effluent. For the first, our objective is to produce a biochar-based palm oil meal sludge through pyrolysis process. The second one is to compare the effectiveness between acid H3PO4 and alkaline KOH. The third one is be able to treat the textile wastewater by using this biochar-based palm oil meal effluent.
In this research, the raw material of palm oil will be obtained from Lepa Hilly 3 oil palm mill and it will be utilized as biomass raw material for the mass production of BioChar via pyrolysis and the preparation of BioChar via chemical activation method. Then the formulated BioChar will be outlined by TGA, XRD, SEM, FTIR, BET and EDX to reduce the activated BioChar physical characteristic and surface chemistry. The effluent of textile wastewater will be used as adsorbent to prove the efficacy of BioChar. At the end of the test, there will be a comparison between raw biochar and also chemically activated biochar in terms of adsorbent dosage on total suspended solid turbidity and also COD.
This is literature review. Pyrolysis. Pyrolysis is a thermal degradation process. It converts the organic matter into a variety of products. Pyrolysis form has much higher carbon content. Fourth point is the pyrolysis determine final surface properties and functionalities of the char. And lastly, this method will be enhance properties of the char. Okay, here benefit of biochar to water treatment. For the first, a biochar has a good adsorption performance and recycling. For the second one, a biochar perform experiment on the decolorizing of solution. And the third one, a biochar has a high level of porosity. Biochar also absorb various properties of wastewater. And then for the last, biochar can control of taste and odor in drinking water.
To increase the non-polarity of biochar, the reducing agent was utilized to minimize functional group on its surface. The cross-linking reaction of the biochar surface and the modifying agent is caused by an increase in oxygen and nitrogen along a decrease in carbon. The increased nitrocellulose ratio indicates the more nitrogen-containing group, which are responsible for the basic properties of biochar surface. This improves the absorption of negatively charged ion as well as organic compound from wastewater. Dye are categorized based on their use and chemical composition and are made up of chromophores which are responsible for dye's color. Chromophores are the part of molecule which are responsible for color of a particular dye, while hexachrome are the part of molecule which provide support for chromophore for fixed color on the fiber and increased intensity of color. The color index contains information on over 8,000 different dyes, and dyes are divided into two categories as like industrial application and chemical composition. The dyes are classified by their chromophore in terms of chemical composition, which is azo dye, nitro dye, anthraquinone dye, toluene dye, and also indigo dye. Whereas the dyes in terms of industrial application, which is modern dye, dispersed dye, direct dye, wet dye, and also in-grain dye. Among the other chemicals in textile industry that need to be eliminated, textile dye are considered the most important pollutants. Every day, the textile dyeing industry generates a large volume of effluent and solid waste ingredient. The textile industry is the biggest consumer of dye stuff, and industry-generated wastewater is one of the major sources of water contamination. Toxic dye, organic matter, and heavy metal are all present in the textile wastewater. The metal contained in textile wastewater has been discovered to be carcinogenic, and heavy metal like iron, lead, nickel, copper, zinc, and chromium are found in the trace quantity in textile dyeing effluent. Dye effluent may contain chemical that are teratogenic, radioactive, mutagenic, or carcinogenic. Because of their complex aromatic molecular structure and synthetic nature, most dye remain in the atmosphere for a long time and are difficult to degrade.
Okay, next is the list material of biochar. For the first, our raw material is from Lepa Hilly 3 palm oil mill. To produce biochar, we use a carbonization process. In this process, we use a muffle furnace as our pyrolysis process. The third one is the activation of biochar. To make it raw material into biochar, they have two types of activation, which are physical and chemical activation. By this project, we use a chemical activation. We use a potassium hydroxide KOH as alkaline and phosphoric acid H3PO4 as acidic chemical activation. Next is a biochar validation. We use a TGA, XRD, SEM, FTIR, BET and EDX analysis. This is the list of material for textile water treatment. Our textile water effluent as a water sample is from Tenun Pahang Diraja. Second, for our water treatment is use a biochar from both chemical activation. And last, for water quality validation, we use a TSS, turbidity and also COD analysis. Okay, next, the figure below is the flowchart of this project. Okay, to know detail on our project, we will go to the next slide. Okay, here is the methodology to produce a biochar. At first, we collect raw material from Lepahile tree palm oil mill and store it at temperature below 20 degrees Celsius. This is because we want to avoid the bacterial contamination. Second, washing by tap water. And the next process is the cut raw material into small pieces. And then, to achieve a consistent weight and eliminate moisture from the content, the raw material of POME is dry at 105 Celsius for 24 hours. At the step 5, POME will be sieved to a uniform size of 0.55 mm using a mechanical sieve shaker. At step 6, the dry POME will be carbonized at 300 Celsius in furnace for 60 minutes. Next, chemical activation for 24 hours. In chemical activation, the carbonized POME is activated with phosphoric acid or alkaline potassium hydroxide as activating agent. For a step 8, to eliminate any activating agent compound, the mixture will be rinsed with distilled water. This step will be repeated until the washing solution reach a neutral pH value. Then at a step 9, the product will be dried for another 24 hours at 105 Celsius to produce a constant mass. The dry product will be crushed and sieved to a size of 0.15 mm before it's labeled as a biochar-based palm oil meal. For the last step, biochar making is validation by using a TGA, XRD, SEM, FDIR, BET and EDX analysis. Okay, next is the methodology of textile wastewater treatment. For the first, we collect effluent from Tenun Pahang Diraja. Second, the sample were transported into a 4 liters container to a UMP laboratory for examination. And to avoid contamination of the wastewater sample, we have to place into the freezer at below 20 degrees Celsius into chemistry laboratory UMP. So the third validation is the TSS, turbidity and COD. Then comparison with two different chemical activation, and lastly discuss and recommendation.
Sample analysis. COD, chemical oxygen demand, is to determine the oxygen depletion level in textile wastewater before and after. TAG, thermogravimetric analysis, is to determine the stability of the material and volatile compound. The viable functional group in adsorbent will be determined by using FTIR, Fourier transform infrared spectroscopy. SEM, scanning electrons microscope, will be used to examine raw biomass, biochar and also chemical activated biochar. The crystallinity of the biomass will be determined by using XRD, X-ray diffraction. The basic surface area and infrastructure of the adsorbent will be determined by using the analysis of Brunauer Emmet Teller, BET. Biochar not only has good absorption performance and low price, but can also recycle and other excellent performance. It is widely used in water treatment. Biochar can be used either alone or in combination with other water treatment technologies. In order to maximize the absorption capacity of biochar in water treatment, better service for water treatment saving costs, reducing energy consumption, improving efficiency, become a basic research criterion. In the modification of biochar, the application performance of biochar in future water treatment will be higher. Lastly, by the end of this project, we hope that we could successfully generate the biochar based foam, which is then can be used to treat textile wastewater. Thank you.